Lesson 10 is on surface area, and surface area is always expressed in square units. And it's really just a lot of formulas in this, but there's also, I want to show you a way to kind of make sense of the formulas. We're going to look at 6 different kinds of shapes, triangular prisms. This is an example of a triangular prism, or any kind of prism. A prism has 2 sides, 2 bases, 2 faces that are the same shape. They could be, this is a triangle in this case, which is why it gets its name as triangular prism. But the base could be a square, it could be a pentagon, it could be anything. Pentagon base would be called a pentagonal prism. But the formula is the same for finding the surface area, which is just how much space all the areas. If you unfolded it and made a net, which is a net of a triangular prism, if I just kind of unhinge all the sides, I would have 3 rectangles, one here, here, and here, and then the 2 triangles. You can kind of imagine folding this all together and it would look similar to this shape. So to find the area of a triangular prism, I have to find the area of the 2 bases. And in these formulas, this capital B always stands for the area of the base. So you have to know that the formula for finding the area of a triangle is base times height divided by 2. Be base times height, or on this be base times height divided by 2. So you have to double that area because you have 2 of the triangles. Then find the area of the rectangle. The area of the rectangle is lowercase b, base times height. I'm going to do a couple demos with some of these, but not all of them. So I'm going to take a couple easy ones and one that's more complicated. To find the surface area of, this is called a rectangular prism. I forgot to write the name up. This is a rectangular prism. You can put it up here. Rectangular prism. Because all the sides are rectangles, except for 2 sides that are, well, all sides are rectangles. That's why it's called a rectangular prism. So it has 6 sides, and you find the opposite sides match up. So I can actually kind of color code the sides that match. That's why you see the double the length times the width. We can let that be this rectangle and this rectangle. So the rectangle, this rectangle could be length times width, length times width. We have 2 of them. Then we have the bigger, larger sides. That could be length times height. And then the width times the height would be the other 2. Other color here. I'll do purple. So we have these matching sides, sides that are opposite each other. So instead of adding 6 numbers, we can add 3 numbers 2 times each, which makes the formula a little simpler. This is a cube, and this is one of the easy ones I'm going to demonstrate. If this cube, and this actually does have every side length is 2 inches, which means this is 2 by 2. 2 inches times 2 inches would give us 4 square inches. So this would be 4 square inches here. And kind of a nice way to do these problems is to draw a net of the shape and just fill in each section. It's kind of an alternative to using a formula, but formulas are nice too. And I can have 1, 2, 3, 4, 5, 6 times 4. 6 times 4 square inches. Don't lose track of the labels. Would mean that the area of the surface area of the cube would be 24 square inches. Then I have a square pyramid here. It's a pyramid because all the sides are rectangles except for one, and that one that's not a rectangle is the base, and the area of that is designated with capital B. It could be a rectangle, it could be a pentagon, it could be an octagon, it could be any kind of shape. If it was an octagon, I'm not sure how you find the area of an octagon. I could divide it up into various triangles and figure it out. But again, you can always have triangles as the other faces. So you figure out the area of the base, and then you add all the other areas together. Then a cylinder has 2 circles, so that's where you get the pi r squared to figure out the area of this circle, this base, then this base. Multiply it by 2 because the 2 are exactly the same. And then you might recognize this part of the formula as being the formula for circumference of a circle. And if you kind of split this and unrolled it, this distance would be the circumference of this circle. So the 2 pi r is the circumference of the circle, and the h stands for the height. So if I wanted to, this is the one that I wanted to do that was a little bit more complicated. If I apply the formula, I'll put in 2, I'm going to just use 3 for pi to make it simple. 2 times 3, and I said this little circle is an inch. I made that a really easy number, times 1 inch squared plus 2 times 3 times r again is 1 inch times the height 4 inches. So I multiply this together, just the numbers, well, I have to do 1 to the second power, 1 inch to the second power, which is 1 square inch. So 2 times 3 is 6, times 1 square inch is 6 square inches, plus 2 times 3 is 6 times 1, it's still 6 times 4, 24, and inches times inches gives me square inches. So it's plus 24 square inches, or a total of 30 square inches. So that would be the surface area here, so 30 square inches. I think I might have mentioned, but I want to just say it again. It's important to see that when you're working with surface area, everything that usually you're adding some things together because you have various faces that you're adding up. But each face by itself has to have a length, two linear straight line dimensions multiplied by each other to get square units. So here it's length times width gives you the square units, length times height, width times height. When you do something with a circle in it, like the cone, the radius is going to be some unit of measurement, like inches times inches, another inches, and then the length is going to be the slant height of the cone. And actually, we're talking about that. I'm going to show you the cone. So the surface area of the cone would be the area of the circular bottom, which is pi r squared, and r would be the radius of the circle from here, from the center out, or from here out. That's this r here, and the same for this r, but the L is the distance from a point on the circle to the tip of the cone, also called slant height. So that's the numbers that you would plug in to calculate the surface area of the cone. But again, you get, it's like inches times inches when you do this. You'd always get square units when you're getting surface area, because it's another area. So that's it for just the basics of this section, surface area 810.